Hi everyone, today we're going to begin 10.2 and that is on graphing square root functions. So in lesson 10.1 we basically look at the general idea of how a square root or cube root function would look like, and we just use decimals to confirm that we have found the inverses. So we were more like exploring the inverse functions of the square and the cube function. So now that we know what the inverse functions are, which is square root and cube root, we're going to actually look at how to graph those manually. So now we're not going to be relying on the graphing calculator so much. So the transformation, the idea of transformation is going to be very important because we're going to be using the transformations to drive the new graph that we're going to obtain. So we're going to look at the general equation again for a square root function. So you keep seeing a, b, h, and k because it's the general equation that we keep using. But now notice that this is a square root function instead of a square or a cube. So we will be looking at the graph and the transformation. So let's take a look at the actual square root function. So we have f of x equals the square root of x, and everyone knows that is the inverse function for the x squared, right? So the inverse of a quadratic function is x squared. And this is a one-to-one function because we've already restricted the domain to the positive side. And so you see the domain is restricted to positive side, and the range is also positive because if you look at this graph, it's actually going to the right side, right? So it's only going to the right side, and it's only going above 0. So therefore, that's restricted already for x and y, the domain and the range. Now, if you take a look at the end behavior, as x approach, if you remember, like this graph is only extending to the right hand side. So you see that there's a dead end over here. So there's only one side for the end behavior. That's as the graph approach the positive infinity side, which means the right hand side, it's going to the right. So as you approach a right hand side, f of x is going to be going up. So here we go, the arrow is definitely pointing up to positive infinity. So it's going up and up, right? And so what does the graph look like when x equal to 0? So basically we're just taking the square root of these numbers. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 gives us 2. And square root of 9 gives us 3. So that's what makes up the square root function. So if you look at 0, 0, it's here. 1, 1 is like right here. 4, 2 is like right here. And then 9, 3 is off the chart. But these 3 points that I have here have a special name. Does anybody recall what these points are called? Anybody? Anybody? I hope you guys said something about reference points, because those would be the reference points that make up the square root function. Here is a reminder about the transformations again. Remember the number in front, A, tells us whether we're going to have a vertical, stretch, or compression. The number inside, B, is going to be a horizontal, stretch, or compression. H is going to tell us going to the left or going to the right, and then K is going to tell us whether the graph is going to be going up or down. And here are some basic transformations that just use these transformations that we just named right now. So let's take a look. As you look at the equation, you will get better at identifying the transformation. So here in the first equation, we notice there's a negative there. What is that associated with? That means usually there is a reflection across the x-axis. Remember that? And then minus 5 means we're going to go 5 units to the right. And then 3 in the back is actually 3 units up. So you guys can practice this as we go along, and then by pausing the video, so you can try guessing what it is first before you hear the answers. There's a 2. There's no number in front, so there is no vertical, stretch, or compression, but there's a 2. Remember what makes a 2 is 1 over 1/2, right? So B is actually equal to 1/2. So we actually have a horizontal compression factor of 1/2, right? And x plus 4 means we're going to go 4 to the left. And then 1 in the back means actually 1 up. That's normal. Next, we have a negative inside, which means we have a reflection across the what? The y-axis. Remember, outside is x-axis, inside is y-axis. And then we have a 1/3. Well, actually, because B needs to be underneath 1, so B is actually equal to 3. So that's a horizontal stretch factor of 3. And then the 6 negative is 6 down. Those are the transformations associated with this number here. Next, we have a 0.4, which is less than 1, right? So A is less than 1 means we have a vertical compression factor of 0.4, or you can say it's 2/5. That's actually equal to 0.4. And then 4, it's a plus 4 inside, so it's 4 to the left. 4 units to the left, and then we have negative 10, so that's 10 units down. So hopefully you've had some practice with this, and we're going to be moving on with more practice right now. So let's name quickly the transformations that are associated with these. So take turn to verbally describe. So you are going to, hopefully you have a partner that you're working with, and then you can just take turn naming it. But if not, you can practice this on your own. So quickly, x minus 2 means just 2 to the right. X plus 2 means 2 to the left. Minus 2 outside is 2 down. And then plus 2 means 2 up. And then 2 outside is just vertical stretch of 2. And then 1/2 outside is vertical compression factor of 1/2. Negative means there's actually two things. It's a reflection across the x-axis, and there is a vertical compression factor of 1/2. So that's two separate things. 1/2 means less than 1, so it's a compression. Negative means it's a reflection across x-axis. And over here, we have reflection, x-axis, and then we have a vertical stretch factor of 2. Inside, we have 2 underneath. That's actually a horizontal stretch factor of 2. And then we have 2, which means it's actually 1 over 1/2. So B is actually equal to 1/2, right? So that's a horizontal compression of 1/2. And this is a vertical stretch. I'm sorry, it's actually horizontal stretch because it's inside. Horizontal stretch of 2. And then also we have a reflection y-axis because it's inside, right? And then here we have a reflection y-axis again. And then also horizontal compression of 1/2 because the 2 is like 1 over 1/2. So B equals 1/2. Hopefully that's more practice for you. And we're going to continue with the next slide. And here is a quick review of the reference points. So take a look at these 3 points again. Remember, those are the 3 points that make up the square root function, right? So here we have the 3 points. And we're going to actually do a problem that's dealing with square root. So you have the equation here, g of x equals 2 times x, the square root of x minus 5 plus 3 in the back. So given this equation, we're going to always start by naming the transformations because we just had a bunch of practice with naming the transformations, right? So the first thing we notice is there is a 2, which means it is a vertical stretch factor of 2. And the next thing we notice is there's a minus 5 inside, which means there's 5 units to the shift to the what? To the right. And then there's also a 3 in the back, so that's 3 units up. So we're going to actually identify what is associated with the x and what is associated with the y y function. So we're going to actually add another line here, and we're just going to call this the x, and this is the y transformation. So for the x equation, anything that's inside the bracket is going to go with the x, right? So there's actually only 5 units to the right. So going to the right is add, going to the left is negative, right? So to the right 5 means we have x plus 5. That's my x equation. So very important, you have the x equation. And then the y equation, we're just going to read the whole bracket as the letter y. So everyone watch. 2y plus 3 is going to be my y equation. So I'm going to put my y equation like right here. 2y plus 3. So that's my x and y equations for the transformation. Now I'm just going to do the math. That's going to show me where the reference points are going to end up. So we begin with these 3 reference points. We're going to end up with new points because of the transformation. So here's the x value. Here's the y. So the x part, I'm going to do 0 plus 5, which is 5. 1 plus 5, which is 6. And then 4 plus 5, which is 9. So I've got 5, 6, and 9. For the y value, I'm going to work with the y. So that's going to be 2 times 0 plus 3. That's just 3. And then we got 2 times 1 plus 3. That's 5. And then we got 2 times 2 plus 3. That's going to be 7. So the new points are 5, 3. So 5, 3 is right here. 6, 5. That's going to be like right there. And then 9, 7. So here's 9, 5, 7, something like right here. And I'm going to draw, since this is a square root, I should follow the square root shape, which is kind of like a curve arrow this way, right? So here is the new graph. That is what the transformed graph looked like. It's looked like it's been vertically stretched by a factor of 2 and then shifted 5 units to the right and 3 units up. And that's what the new graph looks like. So we're going to have more practice like this so you can get familiar with this process. Because this is the same process that we're going to be using the entire year with all kinds of functions. So very important that you learn this process. So let's practice again. With any new skill, you need practice, right? And so as you know, we're always going to need the x graph, x chart, and the y. So we always want to make two columns, okay? So here's the equation. We're going to start by naming the transformation. So we got a reflection across the what? X-axis, because there's negative in front. There's a vertical stretch factor of 3. And we're going to also go 2 units to the right and then 3 units up. So what goes with the x? Anything inside goes with the x, right? So we got 2 units to the right. Remember, going to the right is add, going to the left is subtract. So that means we have x plus 2 is my equation for the x transformation. And then the y, we're just going to read everything like this. So it's going to be pretending that this is y. So it's negative 3y plus 3. It's easy, right? So negative 3y plus 3. So we are ready to do the math. So we got 0 plus 2, which is 2. 1 plus 2, which is 3. 4 plus 2, which is 6. So we got 2, 3, and 6. And then next we got negative 3 times 0, which is 0 plus 3. So 0 plus 3, that's 3. And then negative 3 times 1, that's negative 3 plus 3, which is 0. And then we got negative 3 times 2. Negative 3 times 2 is negative 6 plus 3, that gives me negative 3. So here are my two new points, 2, 3, 3, 0, and then 6, negative 3. Okay, so we need to follow the curve. So notice, guys, we have a reflection across the x-axis, which means it's flipped. If the original graph is like this, then we can expect the new graph to be flipped like this, right? So we need to draw it in the shape of a flipped graph, and that is what it looks like. So does this look like the graph is reflected across the x-axis, and it is a vertically stretched by factor of 3, 2 units to the right and 3 up? Yeah, it looks like this. So this is the new transformed quadratic square root function, okay? And hopefully now you're better at this. We are going to have you try another one. So you can go ahead and pause the video and try it before you actually look at the answers. Hopefully you've had a chance to try the problem. And here is the answer. So looking at the equation, we have a reflection across the y-axis, because it's inside, right? So it's reflection across the y-axis, and then we got 2 units to the right and then 1 unit up. So those are the transformations. And we also have a horizontal stretch factor of 2 because of that 2 right there. So B is actually equal to 2. So we are ready to write the equation. So everything that inside is going to go with the x, right? So this one looks a little messy. So we've got 2. Remember, B equals 2, right? So the equation says bx. So that's 2x And then we are moving to the right, right? So we're going to go, right means add, left is subtract. So we're going to go right 2. So it's 2x plus 2. And because we have the negative right there, so it's actually should be negative 2x plus 2 as the final x transformation. And the y, we're going to read everything in the bracket. So let me erase all of this so you can see it. We're going to replace everything in the bracket, just call it what? Y. So it's actually easy, y plus 1. And we're going to ready to do the x. So we're going to have negative 2 times 0, that's 0 plus 2, that's 2. Negative 2 times 1, that's negative 2 plus 2, which is 0. Negative 2 times 4, that's negative 8 plus 2. It gives me negative 6. And then let's do the y part. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So we got 2, 1, which is right there. 0, 2, which is right here. And then negative 6, 3. Whoa, looks like it's going to be way out here. And then 3 is up here. So let's pretend that there's a dot right there. So we know that this graph looks something like this, guys. And let me try to change the color so you can see it better. Here is the graph again. So that's the transformed graph because there's a reflection across the y-axis. That's why it's pointing to the left now. And so hopefully that makes sense. And what I need you to do actually is now go ahead and enter this equation into decimals to verify that that is what the graph looks like. That's the best way to confirm. Go ahead and go back to the other two problems that we did and use decimals to verify. So at this point, if you haven't done so, go and verify all your answers before you move on. And now that you're ready to move on, you're going to try one on your own. And again, don't forget to use decimals to verify your answer at the end. So here is the equation. So based on that, we're going to name the transformation. So what do the transformations look like? So we got a b equals 1, right? That means it's going to be a vertical. B is actually 3, so, sorry. So verticals, it's not vertical, it's a horizontal stretch factor of 3. Okay, so we got a horizontal factor stretch by a factor of 3, and then we got 2 units to the left, and then 1 up. So those would be the transformations. So everything inside goes with the x, right? So we got 3, because b equals 3, so it's actually 3x, and there's no negative, so it's just 3x, and then we are moving to the left, guys. Going to the left is minus, going to the right is add, so we're going to have to subtract 2. So 3x minus 2 is your transformation for the x, and then we are reading everything. Let me get rid of everything here so you can see it. It is reading everything underneath the bracket is y. So that's y plus 1 for the y. So that's easy, right? We're going to do the math now. So 3 times x, that's 3 times 0, it's 0 minus 2. That's 3 times 1, which is 3. 3 minus 2 is 1. And then 3 times 4 is 12 minus 2, which is 10. And then for the y, it's 0 plus 1, which is 1. 1 plus 1, which is 2. 2 plus 1, which is 3. So we got negative 2, 1. Negative 2, 1. We got 3, 2. And then we got 10, which is way out here, and then 3. So here is what the new graph looks like. Kind of flat, but it still should be in the shape of a curve. So go ahead and use decimal because it will give you a better picture. Mine is just an approximate. And so there is the graph for the transformed equation. It shouldn't look like a flat one. So let me try again. It should be negative 2, 1, and then 3, 2, and then 10, 3, somewhere out here. I think it's... So hopefully you can see a better picture in decimals. That's the best I can do. And here is a discussion question. What effect do h and k have on the domain and range of a square root function? So the domain, if you actually look at the equation, f of x equals a square root of b times x minus h plus k, right? So h and k actually is actually that initial point. So if H and K, H tells you that you're going to move H units to the left or to the right, right? So it goes either left or to the right, and this one goes up or down. And so the domain is restricted. Remember, you cannot have anything like negative underneath. So in fact, X must be greater than or equal to H. And then for the domain, and the range is either going to be Y. So if you have a graph that is going this way, so you're going to have X greater than or equal to H, right? But if it's flipped, then and it's going to the left, then you got X is less than, right? So for the range, it's going to be Y is going to be greater than or equal to K, or if the graph is flipped this way, then it's going to be Y less than or equal to K. So hopefully that kind of tells you what the domain and range is. And that's the end of the lesson. So go ahead and get started with your homework assignment in Google Classroom. Have a nice day.